Welcome to the Energy Manager's Playbook, produced by the IESO under the Save on Energy brand. I'm your host, Jay Mullen. Today's episode is a special edition. In September, the IESO hosted the 2025 Energy Management Excellence Awards, where we recorded 2 panel conversations with this year's award winners and are sharing them here so you can hear about what contributed to their success and how they are overcoming challenges and developing new approaches. We begin with the morning panel, Order of Operations, prioritizing operational improvements, efficiency upgrades, and efficient electrification. It was moderated by Michael Oriahi, Capability Building Advisor at the IESO, and featured representatives from this year's winners, Nicholas Dumoulin from DREAM, Timperon from Algonquin College, and Allan from the Hospital for Sick Children. You'll hear how they decided what came first and what could run in parallel, and how metering, building automation systems, and recommissioning help prepare them for electrification. Let's listen.
So the first panelists we're going to have the team from Sick Kids, Algonquin College, and DREAM. Could Nicholas, Graham, and Allan please join us on stage? This morning's session is going to be focused on operations, and with operations, important thing is decision making, prioritizing things. So how do you decide between making energy efficiency decisions, as well as upgrades, and then going all the way down to electrification? And in what order should things be done? So often we usually hear that the proper order to start with electrification is energy efficiency upgrades, then optimizing your HVAC system to reduce your loads, and then electrifying. In energy efficiency, energy management, the idea is always first, you take energy efficiency measures, you optimize your HVAC system, and then you electrify. But often, that's not always the case. So my first question to the panel is, in your experience, does it always follow that part, or does it differ sometimes?
Hey, good morning, everyone. So we do try to follow that when we can, but the reality is, like in particular for us, we're working in tenanted buildings, office towers, or multi-residential buildings. So we have to work around the occupants of the building, especially if office towers. We have to go and replace a lot of times the HVAC equipment that's on the floors in the tenanted space. So we can't necessarily do that when a tenant is placed. So we're really looking at opportunities when we have tenant turnover to then replace the HVAC equipment on that floor and do those deep retrofits so that we can upgrade the base building heating and cooling plants to decarbonize later. So, putting in equipment that's low temperature, hot water systems so that we can make it easier to electrify, put in those air source heat pumps, really important. This takes a long time. So we've been doing this in some of our properties for 3 years now, and we're only like halfway through because we're just being very opportunistic in terms of when tenants are in place and when they're not. And so, yes, we're also putting in our BS systems, we're upgrading our lighting when we can, but we're doing this in parallel by necessity.
Thanks, Nick. Graham?
So, hi, my name's Graham Timperon. I'm the energy manager for Algonquin College. So I typically look at a 3-phased approach with energy efficiency. It starts in the operations team room where I sit, listening to the guys talk, what's working, what's not working. I often find amazing ECMs, energy conservation measures, just by an HVAC tech complaining about how a system's not working, and just a quick look at that system, you'll be able to tweak it, tailor it. Secondary is whenever we're doing improvements, if we can do a feasibility study with an energy audit attached to that, that's a great way to catch anything. Sometimes there's no funding or there's no available budget for that, so you might have to skip it. So it's just recommendations in the spec, just using your skills as the energy manager to make sure that the design engineers do things correctly, catching them at the start. And then probably the Cadillac option would be before we do any major capital to recommission the building. Existing building commissioning, obviously, most of you are aware there's an incentive open right now from the IESO, so that's a really great way to catch. Just bring your building down from how it's operating to how it should be operating now. We're always finding huge savings in that process. So those are the 3 phases, and a lot of presentations to management have got them listening now, so I probably had to present this strategy 3 or 4 times all the way up the chain, but now they basically just copy my words. So that's the way a good energy manager, you sit in the background and hope to hear your words recited from management back down to you.
Allan?
Good, thank you. Yeah. The efficiency upgrade first, and then electrification is common sense, but not always that clear. Like at CK Research Tower, we are kind of a back-forward pattern. And we do retrofit first, and then electrification, and then retrofit, and repeat that pattern. And first step give next step at the foundation, and next step is based on what first step learned, right? And for example, we start from separate heating system with low temperature heating and high temperature heating, and we group equipment compatible with low temperature like reheat, fan coil unit, and separate some potential troublemaker, for example, reheated panel that not working well with low temperature heating. And then that way we are able to handle the majority of the base load. And then we electrify the building using heat recovery chiller. And then now we are working on add additional heat source and heat sink into the system. And then next step, we're going to do a diabetic humidification. So after all this done, we probably leave minor 5% high temperature load, maybe need to be handled, either use electric resistance or maybe future technology. And in parallel to this stream is recommissioning, because that fill the gap between big retrofit. And so we are not strictly follow upgrade first and then electrification. We try to make it flexible, and wherever opportunity come, wherever technology is available, we sequence the electrification process in that way.
A quick follow-up to that, Allan. Actually, to everybody, considering the fact that it doesn't always follow the same sequence, it varies based on the building type, based on end of life, and various other factors. A major reason why it's always recommended to reduce your load before electrifying is to avoid things like oversizing. When in situations where it doesn't follow those sequence, do you have any strategies to avoid oversizing in the future?
Yeah, I mean, one is really collecting data, right? We want to make sure we have building automation systems and the sensors in place that we are actually tracking what our load profiles look like. So that's really, really important as a first step, so that we can see what is the actual peaks and valleys. We're not just looking at the nameplate of our boilers and sizing based off of that, because we all know a lot of times those have been oversized. We make sure we talk to our operations and how they operate the buildings. How are you operating the buildings in the coldest days of the year? That tells us a lot of how we're actually using the equipment in its most stressful, maximum conditions. So we make sure we have those conversations. We track that, and we track the data and use that to inform ourselves. And from there, we can feed that into energy models where, hey, this is our baseline, but with these additional ECMs and conservation measures where we're going to reduce energy in these other areas, we can get into a ballpark that's more reasonable add a little bit of tolerance on top of that, and we're still better off than just looking at the nameplate we were originally going to probably use if we were going to be really lazy about it.
So at Algonquin College, we actually had a bit more of a challenge here. So we put in a combined heat and power plant about 4 years ago. So when I started, one of the things first discovered was we didn't have that historic data. Not only did we not have it, but the trending wasn't set up to even record it where it was potentially available. So we had to build a baseline. And then I'll even talk, so going back to electrification, because we're a combined heat and power plant, if we electrify, that's gas either way, right? Like we're burning, we have 4 megawatts of power generated through natural gas, which is covering in the summer 80% of our electrical load. As a Class A, which is, Class A customer, that's really good for us. We can almost go 90, but we're not quite looking at direct electrification because it's just pushing our energy use to natural gas because we generate our own electricity. So there's a challenge there of how much we want to electrify because our cogen plant is only a few years old. It's not like we're going to get rid of it anytime soon. As well as the ability for, if anyone's aware, Ottawa's got a really constrained grid. So Hydro Ottawa is not really keen on us getting rid of those units as well. So we're looking at a 20-year plan of, well, if we're going to get rid of those cogens, which is 85% of our GHGs, what's that going to look like? And this is an opportunity to give a shout out. Enbridge is really helpful as well. IESO we work heavily with, but Enbridge is always there. They have the similar programs or whatnot. So hydrogen's, we're starting to look at a 15-year plan to bring hydrogen into the campus to be using, and what that's going to look like for our power generation. So they're already starting to get ready for that for us. Yeah.
Anything to add, Allan?
Yeah. I have a little bit additional comment on how we use data, make clear decision. We start from a common heating degree day, cooling degree day. We did things a little bit extra is that we use Power Automate Flow to automatically draw, download utility data and extract key information from the bill and store into a database. So once the data is there, you can, next step is just a click and do the calculation. We also use EMEAs, Energy Management Information System, and the Power BI to get additional insights in how building operate, and that help make a lot of, provide a lot of visibility that the traditional tool does not have a capability to do so. And we also use AI. AI open a new window to us. It predict issues and uncover hidden opportunities. We use AI for a lot of things, building optimization, and also even like build model for utility budget forecasting and chiller simulation, etc. So we try. We are not afraid of trying new technology, and we are proud to be part of the first Eat Crab team, and I can tell you it tastes great.
Thank you. I'm going to open it up to the room. Does anyone have any questions, please?
I do want to ask a question to Graham. So, one, I really love that on a soft skills panel, you're saying one of the key things is go to your operations team and listen to them. And then you said, when you hear from them a complaint about something that's not working, you can usually find a energy conservation measure by looking. I think you said you look quickly at that and you can find the measure. Okay, so I know you, and I know you can do that, but not everyone can do that. We also heard from Jim that we could be looking at 20 plus hours of AI tutoring for ourselves every year. So if I could get some AI tutoring, what would I want to focus on to position myself to to be able to do what you do and just say, oh, okay, I'm going to quickly look at this diagram. Oh, I found the energy conservation measure.
Thanks, Andrew. That's a pretty tricky question. So the basics of operation. So like the big things is why is this system running? Like why is it on? Does it need to be on? Is it the right temperature? Is it doing the correct job? Is anybody complaining if I turn it off? Or can I turn it off and nobody's going to notice? I think those big things are, the easiest way to save energy is to turn something off. And that's just the baseline right there. Or to let its temperature drift. So if you can train your systems to that, you can cut a huge chunk of your energy by even just on the zone level, turning it off during the zones, letting zone temperatures fluctuate during the day when nobody's in a class. For us, it's classrooms, so between classes, letting set points change. So that's the biggest one I would try to be training my AIs on is why is it on, when is it on, and how is it, can I turn it off? That would be the baseline right there that I would look for. Thanks.
Yeah, so at Dream, we have an integrated process with our operations team. We actually use our project management software and have built a form for them to input when they find equipment that's broken or ECMs that they identify. And that goes into basically a central database in our project management software. And then we have regular touch points with them on a monthly basis, our energy management team, where we then discuss those opportunities as we discuss them. And we basically layer in everyone's perspectives. So they go and they tell us, hey, this is what the operational issues is. These are the impact to the tenants and how this is affecting our operations. We then layer in, what we think the utility or cost impact and the GHG impact is of doing nothing if we don't fix this issue. And this is actually where I think AI can be very beneficial. We've started playing around with how do we do these calculations really quickly. We don't need a perfect calculation. We need an order of magnitude. Like, is this $100, $1,000, $10,000 opportunity? Because there's always more opportunities than we have time and resources to deal with. So we need to go find which ones are the most valuable. And so we want to put a little bit of a price tag on that. And so that's what we do. We've been playing around with models where we can do very quick calculations of what we think the cost savings and the utility savings would be from this. We attach that to the opportunity, and then either one of our teams goes and gets pricing to rectify the issue with the vendor, and that together really builds the business case on, is this something that's going to come out of CapEx? Is this going to come out of OpEx budgets? Who has the budget to handle this and when? And that's how we kind of triage. So that's like a very integrated process that lets us scale across our whole portfolio, across many, many, many buildings. So we find this approach has been very helpful to keep everyone engaged. And the project management piece is really important to track all these opportunities because they will get lost unless you write them down somewhere and basically collate everyone's conversation in one area around that opportunity. So it allows all these different individual teams to contribute and actually feel heard and integrated into the process. And now you have someone, we put actions and you're responsible for getting this aspect, you're responsible for getting that aspect. Together we bring it all together, and then someone brings it up to the management tiers to get approvals as necessary. So it works very well in terms of building communication and making sure things don't fall through the cracks. Because a lot of times these things don't happen in a month, right? These things can take months and months in between all the other responsibilities that operations teams have and we have as energy management professionals. So,
yeah. So we talk about AI, how we use AI in building energy optimization and predictive maintenance. I think the most valuable coming from the combination of technology and human being. So now with AI, our operation team began to, asking some sharp questions that never thought before. For example, I want to steal one of the gym example. In a lead building, with one diffuser provide cold air and another one trying to open reheat, how we can solve this question by adjust the supplier temperature so that minimize these two, instantaneous heating and cooling. Those questions, there's no way that operator can handle by themselves. So now with AI, it kind of not just operate the building, operate the one system, but now we are talking about change entire ecosystem with people, with technology, with process. And we are not just use AI, we actually contribute. We build a strategic relationship with a vendor. So we share our experience, share our expectation, give them feedback. And so yeah, we just, I touched the surface level, but I can see the return is great.
Thank you. I think someone had a question.
Thank you. From CHP, and because you have a unit and it's at Ottawa, which is at the end of the line, that's why we're giving $1,800 a kilowatt for anybody who can lower summer peak demand. Are you capturing that heat? Is it being used in the complete benefit of getting as much out of the gas as possible?
Yeah, actually, so we have 2 absorption chillers as well. So in the summer, we're able to run both cogen units at 18.5 or 1.5 megawatts. They don't like to run at their max at 2. And then all the heat is being captured. We're never using our there's a dry cooler for that heat, and when it vents to atmosphere, we're never opening that valve. So we are using all our heat. And then in the winter, we're never turning on we have these old boilers in the old in the buildings that are on the thermal network. They're now not being turned on anymore. So they will probably never be able to be turned on because the valves will dry out after 1 year. So we're fully using the heat. Where the struggle is in the shoulder seasons, because we can't use that heat. There's no demand for heating and cooling. We're using as much fresh air as we can in most buildings, which is better IAQ. So there is a bit of struggle there. Sometimes we can't even run one. We have a microgrid system, which is a brain that's telling us when to run the cogens. Lot of tuning in that system. But heating season, cooling season, we're running really, really well at between 65 and 75% plant efficiency. Shoulder seasons can be a little bit of a challenge. And at a certain point, we flip fully to the grid. Rarely, but yeah.
I'll build on what Jim said, because I went to China where I saw the absorption chillers from Broad, and we presented it to the Ontario Power Authority, how you can use absorption chillers at a much lower kW than a compressor. So I think we have to look at things differently, including nanotechnologies now that I'm seeing from Europe that are applicable to clean the air and also lower cooling. So I think we have to be innovative in some of these technologies, including the windows, where we have companies that are putting secondary glass on New York and Boston buildings and lowering the demand before they put in the heat pumps.
Yeah. The absorption chillers have a lot lower cost operating than the centrifugal sitting next to it.
Especially if you're using the waste heat.
Yeah, they're basically running for free. But the operating costs as well, just the dollars for maintenance is lower on those. Although if you break something, it's coming from somewhere far away and on a boat, and you're waiting 6 months for that part. So hopefully your maintenance contract looks at that, because otherwise your absorption chiller's down for quite a while.
Thank you. Any other questions from the room? I see you're thinking about it. Okay. We're going to pivot a little bit. So you've talked a lot about technologies as well as communicating with your operating team. Besides AI, what are some of the tools that you use in your decision making?
I'm using AI, but not project tracking. I'm just using it for just general. We are looking at using it quite a bit more. It sounds like Allan's, I'm going to talk to him after. His model sounds pretty impressive there. Sorry, I forgot what the question was.
So I know we talked about AI and analyzing data. So what are some of the tools besides AI that you use in tracking your data and analyzing your data?
As much as I wish I was not saying spreadsheets, unfortunately, I spend a lot of time in spreadsheets still. You know, the AI, I'm hoping to replace that. It's unfortunately, it's a tool that I know is reliable and works well. What I'm typically doing is taking my energy audit, you know, master lists of recommendations in that spreadsheet and using filters and just, okay, here's my next 5 projects. Let's see how much incentive I can get for them if I group them together. And then I get some CapEx money and implement. I wish I had something more clever to say on it, but unfortunately it's working. Once I have an AI tool that I can use, I will be using that to manage all those projects.
Simple work sometimes.
So at CK's, in addition to the traditional engineering tools, we also use EMS dashboard and the fault detection system for real-time insights. And I think this is very extremely valuable for operation team that need take quick action, right? So they don't have time to read lengthy engineering report and run their own analysis. And EMS dashboard and fault detection give them a clear instruction what need to be done in a timely manner. Talking about we also use Power BI with Stacks and Python to generate some engineering report, increase the visibility, and share information to other team members and also people across other departments, because that way it increases visibility and reduce the pushback. And for engineering calculation, we developed some code scrap and then translate into DLL so that can be used for directly by Excel to do some component level simulation, like cooling coil performance at a different temperature, etc., and chiller performance at a different supply return temperature and well bulb humidity level. So that somehow help improve some work efficiency. That's what we do at CK.
Yeah, I mean, just to summarize the earlier point, like the project management software has been a big win for us. Of course, we use a lot of metering systems or energy management systems, building automation systems. For Dream, we really put a big push over the last 3 to 5 years to put automation systems into our commercial properties. A lot of these properties are over 100 years old, so they were either like steam radiators or really a lot of pneumatic systems. So we weren't getting any data out of the properties at all to understand how they were operating. We didn't have great insights on what was working and what wasn't, so doing these projects really allowed us to touch all the valves, all the dampers, all the mechanical equipment, and really do that recommissioning effort at the same time. And now we're making sure we have long-term data. So both metering and BAS data, we make sure we trend it for years at a time so that we have that historical data, and that's used in our monthly checkpoints with operations, so they can see what the impact is of them making operational changes. So they can see, hey, we've changed scheduling, set points, whatever that may be, and now we can actually validate and say, hey, this is what the meters are telling us. This is you, not us. This is you making these impacts. So it really helps us, visualize to them, showing them the heat maps and all these types of things on this is the impact you guys are having to the bottom line, to our energy conservation measures, all that kind of stuff. So it really helps inform us. It helps us with our capital projects in terms of sizing equipment. So it's really valuable in a number of ways. Not that automation systems or metering systems are new, but really making sure we're capturing that data long term and utilizing it, really important. This is the fundamental of everything else. But yeah, that component in terms of coordination, task tracking, and opportunity tracking, I cannot understate how game changer that has been over the last couple of years to actually make sure those opportunities bubble up to the surface and actually get actioned. It's not just someone grumbling in a boiler room because that hasn't been working for years. They now get someone that's listening to them, and it gets moved through the system. So it's and we prioritize it, and we talk about why that is prioritized over something else, and all these different issues, because we can't address everything all at once. So it's been very powerful that way.
Thank you. So our MC has told me to get off stage, which means I have just one more question. I'll open it to the room first. If anyone has a question, I would give that to them. Otherwise, I have one last question for the panelists. Kyle?
Kyle from Cities. Barbara stated that question. To everyone, please reach out to us, my amazing team here. One of the things we do believe in is kind of developing as much as possible community practice to share information so we can all get better. Graham, don't worry, I love what Allan said. We use the same engineering tools before we got on to looking at building intelligence systems and maximizing AI. So reach out to this team. And same thing, we love to come visit your campus, your organizations to learn as well, because that's how we're really going to push to get to where we want to. So once again, reach out to myself, Alex, Richard, or Allan, and we'd be glad to share what we're doing, but also we want to learn what you're doing. So that's it.
Thanks, Kyle. I'm still going to ask my question.
So early this year, this summer, we had an IESO event at our research tower. We showcased our AI system in action and some additional energy management tools. And because of common policy, I cannot endorse the vendor name and brand. But if there is interest, we are more than happy to schedule another one. And yes, of course, if there's any question, technical details, we're happy. We are here. We can discuss offline as well.
So I'm still going to ask my question, guys. It's a quick question. As an energy manager, you have to navigate changing policy, financial restrictions, internal restrictions, budget constraints, tenant issues. What would be your one advice to other energy managers while you navigate all of that?
So I'm just going to speak on one in particular that we've been having a lot of success with. So we had a lot of rooftop units with R22. Right now there's an IESO incentive, and Enbridge will kick in. So we have end-of-life rooftop units right now and converting them to hybrid, so heat pump with gas backup, not electric coil. We're doing the gas backup still because the gas is already on the roof, but we're seeing a payback of like one year and a half because the incentives are so high right now, and I'm pretty sure they're going to catch on, and they're going to reduce them. But so we've replaced maybe 20 rooftop units in 2 years, and that would have normally taken us 5 years or 6 years. So we're significantly reducing gas use, which Enbridge is coughing up. And the DX compressors and the heat pumps are the same power draw, so we don't have to worry about building capacity. So we don't have to do that electrical study. And then we're also using our own guys to commission the units. So I'm saving money in a lot of different places why the payback is so good, but the incentives are really good for hybrid rooftop units right now. So just if anybody's got any that they got to get rid of, do it soon because those incentives are likely to change.
Recommendation, we are all ordinary people trying to do something meaningful, and don't be afraid, show your strength and your weakness, right? because really things coming from collaboration. And I want to use a real-world example. Once we were doing the building envelope thermal image, and we have to run drone to scan the building surface. And one of our senior manager told me, actually, you have to report, you have to connect with Canadian Aviation so that they can make some arrangement. And without this kind of connection, you're probably not able, I won't be here anymore, maybe in a jail somewhere. So yeah, so don't be afraid to reach out to other people and get advice, get support from the team. I think that's the key.
Nicholas, anything to add to that? No. Okay, well, could you please give your hands up for this year's winners?
From the morning session, 2 points stood out for me. The order of operations worked best as a flexible playbook, not a fixed recipe. The optimal solution would be to reduce heating demand and optimize existing systems before electrification to avoid oversizing those systems. But they had to work within real-world constraints, such as tenant turnover, internal heating infrastructure, or local grid limitations, as well as being ready to take advantage of opportunities that arose, like new incentive programs or innovative solutions like AI-driven building automation. The other key point was alignment and clear communication across operations, energy teams, and leadership. Using data and aligning efforts around strategic priorities is critical for building and maintaining momentum. The second panel looked at skills energy managers rely on to drive change. The panel, titled What They Don't Teach You in School, Ensuring Energy Managers Have the Right Skills, was moderated by Asia Staples, Program Performance Advisor at the Independent Electricity System Operator, with representatives from this year's winners, Tony Campbell from Landmark Cinemas and Emily Dabrowski from Cemtol Manufacturing, which is part of Linamar. You'll hear how a wide range of skills contributed to their success. Let's listen.
Well, it's a pleasure to be here with you all today and celebrate all these amazing achievements in energy management. Our panel today is What They Don't Teach You in School, Ensuring Energy Managers Have the Right Skills. And I am happy to introduce our panelists if they can make their way to the stage. Tony Campbell from Landmark Cinemas and Emily Dabrowski from Cemtol. So thank you, Emily and Tony, and congratulations. We're going to start off with a question that's a little more technical in nature for energy management. When a lot of people talk about energy management, technical and analytical skills come to the forefront a lot of the time. Can you talk a bit about how these skills are applied in your teams? And maybe we'll start with you, Tony.
So with my team, we spend a lot of time doing analysis of our consumption, our demand. We look at all of our bills. We actually have an energy consultant we work with regularly that helps us with a lot of the advanced modeling in Catalyst Labs. So they're a great partner for us because we don't have the largest energy management team. So we supplement it with outside consultants that help supply us with some of the skills we don't have necessarily within our own team.
How about you, Emily?
So for Cemtol, I'm very lucky to have a team of many different individuals from multiple different departments. So each of us brings a different aspect towards energy management. I do majority of the analytical side of it, and I provide research and ideas towards the table for us to kind of go over. And then from there, we have a team with our general manager, our engineering manager, our maintenance manager, and our LPS manager. And then we all get together and determine which of those ideas are feasible for us to actually implement, how going about the project would occur, and just breaking down the aspects that can be applicable to the facility and the projects that we're doing.
Thank you. It sounds like you have two different scenarios there with how you work with those skills. Yeah. We also wanted to ask about some of the specific projects that you're working on. So, Tony, I think this is the first time we've had a cinema as part of the awards, and you had a project replacing xenon lamps with laser projectors. And can you tell us a bit about that project and how you made it successful?
So one of our biggest projects over the last 12 months was our laser retrofit program. So this is probably something that's a little unique to the cinema industry, but it's a new technology where we're converting traditional projectors with xenon lamp sources, and we're either converting them to laser or replacing them with brand new laser projectors. A laser light source consumes, depending on what it's replacing, anywhere between 30 and 65% less electricity. Plus you get the added benefits of xenon lamps produce a lot of heat. So you have to have a 5 horsepower exhaust fan running for every projector, a lot of HVAC in the booth. We've been able to eliminate all of that with the laser retrofit. We're about 70% through our retrofit program across the country now. And with that, there have been a lot of challenges, not just in the logistics of doing the replacements, because we have to do them overnight, because we don't want to shut screens down and lose out on the revenue. But also in the training, because it's something totally new for our staff. And there's a lot of safety protocols that go along with having lasers in your building that were pretty foreign to our industry and foreign to our staff. So there's been a big learning curve, and my team's done a fantastic job with building a training program, building the documentation, and rolling it out to all of the theaters to make it really successful. And to be honest, we couldn't have done this as quickly as we did without the EPP program from Save On Energy, because it helped fund a good portion of the retrofits.
Thank you for that insight into those replacements. Emily, at Cemtol, you undertook a compressed air nozzle project. Can you talk about some of the challenges that came with that and how you overcame them?
So at Cemtol, originally we just had the regular air guns, compressed air units to blow off all of the parts throughout our entire facility. We never really thought about Venturi nozzles or retrofits for any of those types of situations. So when we heard about it, we really wanted to put it in place in our most impactful areas, so the areas where we use the highest, where the operators are blowing off the parts the most. And at first, it did not go over well. I think a lot of people are very resistant to change. So the second that they saw something new and the second that they felt something different, they didn't necessarily understand the impacts that it could have for energy usage as well as just for themselves. So overnight, they actually swapped them back out and just went back to their old air nozzles, and we just found them randomly scattered around the entire facility. So we had to change the way that we were going to implement it. Instead of just focusing on the highest usage areas, we decided to go line by line and just change every single one of the air guns on that line, and also educate the workers and tell them why it was actually a lot more beneficial to be using these type of air guns. A lot of times with them, they just felt the force difference before it was a really big kickback while using the original air guns. So when they didn't feel that with the new ones, they thought that it was using less force and it was using less power, so they weren't going to have as good of or as efficient of a clean of the parts that they were used to. But once we discussed with them and shared the educational aspects behind the Venturi nozzle system and everything like that, they were a lot more susceptible to the change, and we have actually changed our entire facility to those Venturi nozzles.
Congratulations on that achievement. That's amazing. Since we're talking about skills for energy managers, there's a range of skills. We talked a little bit about the technical and the analytical, but have you come across situations where what do you do if you need a skill that doesn't exist in your team? I know, Tony, you were talking about consultants. Maybe you want to start with that.
Sure. So I don't think anyone can be a master of everything. And you have to know what your skills and expertise are. And then when you're looking at a project, you have to lay out the other skills and expertise that you're going to need to support that. We're a very lean organization. I have a relatively small team for the number of buildings and the square footage we manage, as well as all of the other priorities we manage in the facilities group. So we often have to bring in outside help. And we'll identify a need like we have with Catalyst Labs, where we needed stronger analytical information to make good decisions and to build business cases. It wasn't something that we could do internally. I have an engineering background, but I, don't have the time, and I'm not an expert in all of the different analysis that Catalyst can do for us. They can do advanced modeling and things that we don't have the capabilities in-house to do. So they've been an outstanding partner for us in bringing them in and helping us support and build business cases. And then, often there's other areas where someone on my team may not be the subject matter expert. We need operational support, and we'll bring in someone from the operations group to help us when we're writing new SOPs or changing the way we're doing something. So it's really a collaborative effort where you're seeking out those subject matter experts and bringing them to your team and having them contribute in the areas where you might have a deficiency within your group or yourself or within the organization, and not being afraid to ask for the help, because that's where it all starts. You have to know where you need the help and be willing to ask for it.
Important advice. Thank you, Tony. Emily, how about you?
So at my facility, we've discussed before that I rely heavily on all of the different departments within my energy management team. We meet every 2 weeks to go over different initiatives that we have and different ideas and projects that we can put in place and where the progress is within them. At Cemtol and at Linamar as a whole, we are very fortunate to have a lot of different facilities that we can share different ideas off of. So with a lot of facilities, if they have an idea that has worked within their facility, we have this program where we can actually put it online, give any sort of information that's required for it and how it benefited that facility. And then any of the Linamar facilities can then take it and implement it if they would like to. So that has been something that has been very beneficial to try and gauge new ideas, as well as understanding if something worked at one facility, then you can always just reach out to those people and that project manager to help try and gauge it towards your plant and your facility and the machines that you have, so that it'll be able to work as well. Yeah.
Wonderful to have that cross-facility knowledge to leverage. I'm going to ask one more question, and then I will pause to see if there's any audience questions. So if you're thinking of something, we'll get to that in a moment. I find this really interesting. You both have two very different educational backgrounds. So Tony, you have a chemical engineering background, and Emily, you have a less traditional background for an energy manager in kinesiology and occupational health. So can you talk to us about how these backgrounds and specific training have informed your approach to energy management? We can Thank you.
For me, I'll be honest, the last place when I was in university I thought I'd be working was in the cinema industry. I started my career in industry. I was a polymer scientist. I worked for Procter & Gamble, PepsiCo, some of the largest consumer goods companies on the planet. And some of that experience has helped mold me as an energy manager now, seeing the energy programs from companies like that. I've been able to utilize the cross-industry experience and bring what I think is a very unique perspective to the cinema industry. And then with that, educationally, like engineering in general gives you a very analytical skill set that you can use and apply to solving pretty much any problem, whether it's within your discipline or outside of your discipline. And having that base framework has really helped me in how I approach analyzing a problem and looking at an opportunity. So while my education was one thing, the experience I've gained over a 30-year career has really been what truly has molded me and how I look at energy management and energy management projects and looking at what we can do. And the other big thing is a financial background. You really, like, part of your job as an energy manager is to sell your projects. You have to be an educator, and you have to have a strong financial acumen to be able to sell the project to the senior management group to get the buy-in that there's value beyond just the environmental impact that you're having.
Thank you. Emily?
So I also did not think that I would ever be an energy manager. In university, the only time that I really heard energy, I was thinking about like anabolic respiration and how your body turns glucose into energy. It wasn't necessarily about how to preserve energy in any sort of realm. Then I also had like sports psychology background, so the only thing that I've really taken from that is teamwork really does make the dream work. Having the ability to rally team members and get them to come together and work towards a common goal has been very beneficial. With the educational background as well, I also had a little bit of the analytical aspect and the research aspect to help guide me on this journey. I am very, very new to energy management, and I am learning everything along the way. Majority of the things that I've come across have been through the SEM program or going onto websites and trying to understand what sort of energy initiatives that we can put in place. Like you saw in the video, I had no idea how much energy compressed air actually took. So it's definitely been something that I've been learning throughout this entire journey. And one of the things that's actually going to be helping me a lot is I have applied to be a part of the energy manager course. So hopefully that'll also help gauge my skill set and hope to hone all of those different skills and try and sharpen my understanding of all of those different areas where I can put in the energy management skills that are required to make the teamwork as good as it can.
We'll pause now. Does anyone have any questions? If you can raise your hand, and we'll bring the mic over.
Tony, this question's for you. You spoke about using consultants, and you also spoke about being able to build a business case. I'm curious about how you built the business case for hiring consultants, like spending that money on an external organization to help you with energy management.
So for Landmark, we operate extremely lean. the cinema industry is a surprisingly tight-margined industry. So for me to have all of the resources that Calus Labs can bring to me on staff would be hundreds of thousands of dollars in salary and overhead that we don't want to take on all of the time. So the business case is, in the case of the consultant, they're there when I need them and I pay them for a specific section of time and support, and I'm only paying for that. And I don't have the rest of the overhead of having a full-time body in that role when I really can't afford that within my budget. There's other areas I could spend that money on that would be just as impactful, if not more impactful. And we have a great partner. They do a great job in helping us build the business cases and doing the analytics and doing those things. And because it's their expertise, they're really efficient at it, much more efficient than me crunching it on a spreadsheet. So, or pulling it out of my BAS, or any of the areas that I could possibly get it. I am kind of intrigued about AI now. That, I don't know, Luke, you might be losing some business, but overall, that's how I justify it. It's much cheaper than the overhead of having all of that engineering staff on staff full time. Some other businesses might be able to support that, but for us, it doesn't make sense.
Got another question over here.
Emily, welcome to the energy management profession. I think you're going to do well. One comment, I'm just picking up on both of your aspects is health and safety. And how would you say that energy managers can use health and safety as a skill and almost as a separate profession to tie into energy management?
Well, it's funny you say that because I am actually an environmental health and safety coordinator. And I was kind of pushed into the energy manager role because energy equals saving the environment, right? So I think that it does go hand in hand, especially like a lot of times with energy management, with health and safety, and a few of those different things. You always want to make sure that you're making your facility or you're making your operations as safe as they can be for the operators. So, and as the best that they can be for the operators. So a lot of times by putting things in place that are more energy efficient, they're just going to be better for the operators. Looking from like an ergonomic standpoint, ergonomics is literally the study of how to make your workstation as efficient as possible. So looking at ways to try and minimize human energy and electrical energy kind of also go hand in hand in a lot of different ways that people don't necessarily understand. Even when looking at, did it go out? When looking at the Venturi nozzles and things like that, it had multiple different benefits towards the impact of the overall health of the operators, because not only is it less force on the operator's hands, but it's also a lot less noise and a lot, and so there was multiple things that could actually have been beneficial that could have been taken into consideration and made a better kind of like business model as well.
Thank you for that. Thank you for the question. We're getting to the end of our time here, so I do want to wrap up by asking you both, because we're talking about energy manager skills, both learned formally and from outside of that venue. These projects that you've had so much success with this year, is there one skill you've utilized that you would highlight as being particularly a game changer for you?
For me, probably the big game changer is being a salesman. none of these projects happen without the ability to sell them to your senior leadership and get buy-in and educate them on why it's going to be beneficial to the organization. So if you're not good at being a salesman, it's going to lead to you not necessarily being as successful as an energy manager, in my opinion, because you need that holistic buy-in from all levels of the organization, but especially at the senior level, to execute successfully on projects where you're making large investments.
For me, one of the things that I've heavily relied on is my ability to not only gather information, but hone it into a digestible avenue for multiple different personnel within the business unit. A lot of people don't necessarily understand what 1,000 kilowatt hours saved necessarily means. So when you can put it into perspective that they understand, it makes it a lot more impactful for them. So highlighting that it's a certain amount of dollars saved, or it's turning off a certain machine for a certain amount of time saves this amount of money, and which equals this amount of hours worked. All of that really highlights different different things that are very, very impactful and very important to try and make energy management a positive thing within the workplace.
Thank you for that. And thank you to the audience for your questions and participation.
In this panel, I really loved how they both paired technical rigor with other non-technical skills like sales, training, and change management to ensure the success of their projects and make that change durable with people and processes. I also found it interesting how they recognized when there were gaps in their skill set and how they addressed that, either by leveraging knowledge and expertise within their organization or bringing in consultants when needed. Thank you to this year's winners who shared their experiences on the panels: Dream, Algonquin College, the Hospital for Sick Children, Landmark Cinemas, and Cemtol Manufacturing. Thanks as well to our moderators, Michael Oriahi and Asia Staples, and to everyone who took part in the 2025 Energy Management Excellence Awards. Your projects show what is possible when strong operations, clear communication, and collaboration come together to move energy efficiency forward. You can find videos showcasing the efforts of each of the winners on the Save on Energy website. And if you haven't listened to it yet, check out our Energy Management Excellence Awards recap episode featuring Tam Wagner, Director of Demand Side Management at the IESO. Thanks for listening. I'm Jay Mullen, and this has been the Energy Manager's Playbook, a podcast from Save on Energy.